two things. One is moment of inertia and moment. These two, how to calculate, that you have to learn first. Already, how to calculate moment of inertia, you might have studied in engineering mechanics detailing. You might have studied in engineering mechanics detailing. Anyway, I want to revise it. I want to revise it with one or two problems so that you can find moment of inertia for any cross section, right? And how to find moment, that is the important thing. There are variety of possibilities are there. It may be a cantilever beam, it may be a simply separated beam, it may be a overhanging beam, it may be a point load or concentrated load, uniformly distributed load, uniformly varying load. So there are 3 into 3. There are so many possibilities are there. So in such cases, how to find the moment, bending moment, that is important, that we will discuss later. First we will discuss how to find I, moment of inertia. That's what we are going to discuss now. Let me take this T section. This is T section. For this T section, how to calculate the moment of inertia? How to calculate the moment of inertia? We will discuss. Already you know all those things. Anyway, I want to revise it. So this is a cross section given for us. We need to calculate moment of inertia. Moment of inertia. So before doing this problem, I like to revise you. If a cross section is rectangular, if a cross section is rectangular, then what is the equation? You see, this is a rectangular cross section. This is B, this is D. Then I will say about the neutral axis, center, neutral axis. That is one. Another one is taking moment of inertia about any axis, any axis. See, that this is a neutral axis or central axis. The distance between the central axis and this is y. This is y. This is some one axis. First, this is x-axis. This is x-axis. This is some another axis. If you want to calculate moment of inertia about the center axis, I x-axis, that is neutral axis, then the equation is b dq by 12. B dq by 12. Suppose if you want to calculate, let us say this is OO. If you want to calculate moment of inertia of this axis away from the neutral axis, the distance between this axis and neutral axis y, then you have to use the parallax theorem. What is the parallax theorem? IOO is equal to the same B dq by 12. The same B dq by 12. That is moment of inertia about the neutral axis. Then area. What area? This area. Area into y square. What is y? Y is the distance between the neutral axis and the new axis. This axis. This is another parallel axis theorem. You remember this? B dq by 12 a y square. If it is circular cross section, what is the moment of inertia? Pi d power 4 by 12. Sorry, 64. About its own neutral axis, that is center. About the central axis, it is pi d. Suppose if you want some other axis here, then you take this y, this value plus area into y square. Area into y square. That is the equation. Any axis you can find. If it is about the central center, then it is pi d power 4 by 64 or b dq by 12. Otherwise, you have to multiply the area into y square. This is the way you have to find the moment of inertia. This may be knowing for you. This you know. Now we are interested to find the another moment of inertia for this cross section. So first step is finding the center of gravity. So how to find the center of gravity? So in this problem, The x bar means what? The distance from here, the distance from here, distance from here. If you take the distance from here, center of gravity, x bar will be, x bar is known, x bar is known, because about the y axis, about the y axis it is symmetrical, about the y axis it is symmetrical. So the y axis will come here. So x bar is equal to another, if it is 100, it is will be 50, it will be 50. X bar is equal to, x bar is equal to 50. You can easily, you can find. But what about y? Y is not symmetrical, y is not symmetrical. If your cross section is symmetrical like this, you can easily say center of gravity will be at the center, center of gravity will be at the center. But this is not, this is symmetrical about y axis, so x bar is known, but it is not symmetrical about the x axis. Then you have to find the y bar. Y bar, how to find y bar? Here it is taken yt, here it is taken yt. How to find this value? That is important, that is important. That we are now, we are going to calculate the y bar. So to calculate y bar, there is a equation, there is a equation, that is y bar, or here it is taken yt. Yt is equal to a1 x1, sorry, a1 y1 plus a2 y2 divided by a1 plus a2, a1 plus a2. You can take a3 y3 also, you can take, but here there are two areas, you can divide this into two area. Here you put a line, you take this as 1, you take this as 1, and this is 2, this is 2. There are two areas, that is what I have taken only 2. If there are three areas, then you have to take a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3, right? Now you substitute in this equation, you substitute in this equation. What is a1? 100 into 12, 100 into 12, 100 into 12 plus a2 is, this is 88, 88 into 12, 100 into 12 multiplied by y bar, y1, y1 value. What is y1? You can take some axis as a base, you can take anything, anything as a base. Let us take this as a base, this as a, this line, this is a base, you can take anything as a base. So I'm calculating, I'm substituting all, I'm calculating all the values in terms of this axis, this axis. So a area is 10 into 12 and y bar y1. So the area 1 is this, area 1 is this. What will be the center of this area 1? This will be the center. What will be this distance, y distance, this distance? This distance will be 12 by 2, 12 by 2, 12 by 2. Because it is a rectangular cross section, it is symmetrical cross section, it is symmetrical cross section. About the x axis, about the x axis it is symmetrical, y axis also it is symmetrical. So if it is symmetrical about x axis, the center of gravity will be at a distance of another 12 by 2, 12 by 2 plus area 2, area 2 is 88 into 12. What about y distance? Always we are taking about this axis, we are taking about this axis, y2. So this is the area, this is totally 88, totally 88. It is symmetrical about x axis and y axis. So center will be here, center will be here. What will be the distance? This will be 44, this will be 44. But we are taking about this axis, we are taking about this axis. So 44 plus 12, you have to add this 12. So this is the total distance. Since we are taking about this axis, this 44 plus 12, 44 plus 12, this is y2, this is y2. Then divided by area, 100 into 12 plus 88 into 12. What is the value? You have to find what is the value. Okay, now you have to find the I value. So I value, we need I value, I axis about this axis, we need this. What is this value? What is this value? X yt, this is 29.4, this is 29.4 millimeter. Now I want to calculate another moment of inertia about the centroidal axis, center axis. I want to calculate moment of inertia about this axis. So initially, while calculating yt, we have taken this as a reference. This is a reference. Now we want I about xx. We want only xx. We want about the whole body. The whole body center of gravity is here. This is the center of gravity of the whole body. 1 and 2. 1 and 2. So we have to, if you find the center of gravity of this body, it will be here. It will be here for body 1. For body 1, center of gravity will be here. For body 2, center of gravity will be here. Here. But the combined center of gravity is G. It is here. It is here. Now we are interested in calculating the moment of inertia of combined body, that is Ixx. Now you calculate the moment of inertia of the section 1. This one you find the, but this center of gravity is here. This center of gravity is here, but the combined center of gravity is here, right? But for this body 1, about this center of gravity, its own center of gravity, no? About this own center of gravity, we know the moment of inertia. What is that? B d cube by 12. What is B? 100. 100 into D, 12 cube, B d cube by 12. So what is this? This is moment of inertia of the body 1 about this axis. About this axis. But we want moment of inertia about this axis. We want moment of inertia about this axis. What is this distance? What you have to put area into y square. How much is this distance? We know yt. The total distance is 29. What is this distance? This is 6. This is 6. Then plus area. What is the area? 100 into 12. 100 into 12 into y square. What is y? 29.4 minus 6 the whole square. So this is the what? Moment of inertia of the section 1 about this axis. About this axis. Similarly, you have to find moment of inertia of the section 2. Section 2. This is a section 2. So for this is a center of gravity. This is a center of gravity of the section 2. First, you find the center of gravity about the another moment of inertia of the body 2. About the center of gravity of the body 2. What is that? B d cube. What is B? B is 12. B is 12. D is 88. B d cube by 12. What is this? This is moment of inertia of the body 2 about its own center of gravity. But we want moment of inertia about the combined center of gravity. This one. Then you have to use the parallax theorem. Parallax theorem means you have to put area into y. What is area? 88 into 12. This is area. What is y? This distance is y. This distance is y. How to calculate this distance? We know this is 29. This is 29. Can we calculate this distance? From here to here, this distance minus this distance will give you this distance, right? I want this distance. This distance minus this will give this distance. What is this? What is this? This is, what is this? This is 44. This is 44 plus 12. 44 plus 12 is 56. 56 minus 29. Minus 29.4. The whole square. So this will give you the Ixx. This will give you the Ixx. How to calculate this distance? What is this? This is 44 plus 12. 56. This is right. Now we can substitute the value. Now we can find the value of Ixx. We can find the value of Ixx. Right? What is the value of Ixx? We can see Ixx value is, this is a Ixx value. Okay? This is a Ixx value. Similarly, we will see one more problem. Now, and the last problem, we have taken base at the top. You can take for difference, you can take base at here. Anywhere you can take. Anywhere for your convenience you can take anywhere. So I am taking this for this problem. I am taking base here. I am going to calculate another center of gravity of the body about this one. This is a reference. This is a reference. For body 1, this is what is the center of gravity? Is symmetrical. So center of gravity is here. For body 1. What's the center of gravity of the body 2? It will be here. It will be here. Since it is symmetrical, it's a rectangular cross section, symmetrical, it will be at the center. What about the center of gravity of the body 3? It will be here. It will be here. So now let us discuss about the combined moment of inertia. Combined center of gravity. Combined center of gravity. How to find the combined center of gravity? That we are going to discuss. We are going to see. But this is not similar. About the y-axis, it is symmetrical. About the y-axis, it is symmetrical. So the combined center of gravity will be at this in this y line, in the y-axis, in the y-axis. What about if you take x-axis? About the x-axis, it is not symmetrical. I am talking about the combined center of gravity. About the x-axis, it is not symmetrical. Not symmetrical because this is big, this is small. So it may be, it will be below the center of gravity. This point, below this point, somewhere here. But we don't know the distance. We don't know the distance that you have to calculate. That how to calculate the same procedure. I'm taking this as a reference. I'm taking this as a reference. With respect to this, you write the equation. We write the equation. That is y bar. Y bar is equal to, or here it is taken yb. Here a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. Now, what is a1? A1 is equal to 160 into 20. 160 into 20. 160 into 20 into y1. Y1 is, this is 20. So from the reference it is 10. It will be 10 at the center. 10 plus a2 y2. What is a2? This is 200. 200 into 20. 200 into 20. That is the 200 into 20. That is a area into center of gravity. The total distance is 200. So it will be at the center. 100. Y2 is 100 plus A3 Y3. What is A3? A3 is 80 into 20. 80 into 20 multiplied by, what is the distance? 20. This is 120. Then 80 into 20 multiplied by Y3. What is Y3? This is at the center. This will be 10. This will be 10 plus the total distance. 10 plus 200 plus 20. 10 plus 200 plus 20. This is a y3 divided by a1 plus a2 plus a3. 160 into 20 plus 200 into 20 plus 80 into 20. So this will be, here already it is calculated, is 100. It is 100 millimeter. Actually, this point is, what is the distance? This point, this is 100 plus 20, 120. This is at a distance of 120. But this is only another, this is only 100. So 20 mm below that, 100. Right? So it is calculated. Now we have to calculate the I. I is equal to, first BD cubic 12 for this. This we want to calculate now I about this neutral axis. We want to calculate I about neutral axis. This is a neutral axis or centroidal axis or center axis, what it may be. So it is a centroid for the whole diagram. Centroid for whole diagram. Now we want to calculate about this. Now body 1. Body 1 center of gravity is here. There is a distance. Now there is a distance. Now first you put the BD cubic 12. What is B? 160. 160 into D. D is 20. D is 20. 20 cube by 12. What is this? This is moment of inertia of the body 1 about its own axis. About its own axis. But we want to find moment of inertia about this axis. Now you take this distance. Then area into y square. 160 into 20 into what is this distance? We know the total distance is this is 100. 100 minus 10. 100 minus 10. Then 90. 90 square plus you take now body 2. You write the moment of inertia about the body about its own axis. Own axis. What is b? B is equal to 20. 20 into what is 100? 200. 20 into 200 cube divided by 12 plus 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 what? Area into area. What is area? 20 into 200. That is area into y value. What is y value? This is center of gravity of the body true. This is a neutral axis. We want to find about neutral axis. What is the distance? This total distance is, we know this is 100, this is 20, 120. So the total distance is 120. This is 100. So 120 minus 100, the whole square. The whole square plus plus the you take the body 3. Here b is equal to 80. 80 into 20 cube. 20 cube divided by 12. This will be the what? Moment of inertia of the body 3 about its own axis. Now you take this distance. No. You take this distance. You take this distance. How much it is? Plus area. Area is equal to 80 into 20. Area. What is this distance? From this point to this distance. Right? This distance. How to calculate? We know this is 100. We know this is 100. What is this distance? What is this distance? You find. This is 20. This is 20. Huh? This is 20. This is 100. So then here one 10. Here one 10. This is 20. This is 100. Here one 10. So total distance is 20 plus 100 plus 10. So this will give the what? Moment of inertia. This will give the